Alhamdulillah Rabbil Alameen. Allah subhanahu wa ta'ala give us the ability today also to witness another day, and we are having another class, chemistry again. Yes, last week we did distillation type of separation of mixtures, and we end up with fractional distillation. That's what you see here on the board. Okay, so luckily today I was going through some questions. I saw a GCSE question on fractional distillation. I say, let's deal with that quickly before we go to our next topic, which is the periodic table. Periodic table, yes. We have looked at periodic table before, but now we want to look at it closely. Okay? Now look at this diagram here. Basically, this diagram is showing fractional distillation. That is the separation of a mixture by taking advantage of the boiling point of the different compounds or substances in the mixture. Now, fractional distillation, we are going to deal it when we do hydrocarbons. When we will see fractional distillation at industrial level, where the fractional distillized hydrocarbon called crude oil, which is normally found in many countries, notably Saudi Arabia and the East countries. They get a lot of money from this, but they don't have the technology, so the white man has to go. I don't want to do that anyway. If you look at this, is the mixture we are going to separate. This mixture may contain different compounds. For crude oil, it may contain lowest hydrocarbons to the very high carbons, okay? Now this can be something else we want to separate, okay? When we boil here, there is some heat here. When we start at lower temperature, the compound with the lower boiling point will rise up as a gas, go through the island fillings here, make it for more purification, and the temperature can be more, it will go through here until it is completely evaporated. It goes in the tube, take it away, put another tube, take it away, until all of the gases, all of the liquid is separated. Okay? Look at the diagram closely, because I'm going to put an exam question and ask you about it, yes? So this is called fractional distillation. You have a thermometer, you have a cork here, which is just like a rubber. A cork here, okay? That's called cork. There's a cork here. There's it will be hottest here, as we call it cork. Okay. Now let me draw the diagram, and I'll ask you questions about it quickly before we go to our periodic table. We are going to look at the periodic table closely and see whether we can identify the patterns of the activity of the various elements and how they were discovered in the first place. Now, let me draw this diagram. I'm not very good at drawing, you know that. Okay. First of all, there's a flask. And, okay. And there's a liquid here. Okay. So my hand is not straight. All right. Okay. Okay. Let's say we have heat here. Okay. Now this thing standing on something else, so the level here, and then we have a cork around this. Sorry, the condenser around this. It will condense the gas. There's an outlet here. so that water can go out. Water vapor, yes? Okay. Now this is okay. Now okay. Yeah, Angel. Okay. I've completed the diagram now. You can see the diagram look like what we have looked at in other distillation. Although they are different, but this is a GCSE question, okay? This is a GSE question. Okay, question on distillation. So the GCSE question. Okay. Now this is our diagram. The diagram, the flask contain aspirin and an impurity. Okay, something that make it dirty, okay? But they are all soluble in this solution. So this is a solution, okay? This is a solution. That means aspirin is what? What is aspirin here? What is aspirin and impurity? What are they? There is solute. Okay? So what is the liquid they are dissolved in? Solvent. That's why it's equal to solution. We have done this before. A solute plus a solvent is equal to solution. Okay? Now we have aspirin here. Aspirin, you know the aspirin people take when they are sick. Okay? That's aspirin and some other substance which is an impurity, which make the aspirin impure to drink. Okay? It makes aspirin impure to drink. So you want to separate your aspirin and the impurity all together. Then I ask you first, the first question is, now they said, this is a solution contain aspirin which has a boiling point of 140 degrees. Yes? Aspirin has a boiling point of 140 degrees centigrade. Okay? Now the impurity inside it, the impurity has a boiling point of 187 degrees Celsius. Okay? So basically they give you the idea how to solve this question because they give you the boiling point. The distillation apparatus shown in figure 1 was set up to separate aspirin from the impurity. Okay? The apparatus is not correctly set up. Explain how you would modify the apparatus to make it function correctly. What do you observe first?
There's no rubber bung.
There is no rubber bung here. What will rubber bung do?
It will stop it from the air
Will
running up and out.
When they are heat, some of these things will evaporate because when they reach the boiling point, it's 140 degrees. If you don't put a bunk here, okay, they will go out, in it. Okay, so basically one criticism is there is no bunk here. So our setup is not correct. Okay, there is no bunk there. When the gases rise up, they go out, in it. Yes, that's not correct. Yes, that's number one. Explain number two. Can you see another thing? Can you see something else? How? Can you see something else?
A thermometer.
A thermometer. Why? A thermometer will measure the temperature. Because we are given the boiling point of 140 Celsius and 187. How would you know it has reached 147? Unless we have a thermometer in it. Yes. Now, what does thermometer do?
It measures the heat.
Measure heat. No, measure
Temperature.
temperature. That's the right word. Is heat, yes, but the right word is temperature. It measures the temperature. Do you have any other how do you call it? Defect here? Do you have any defect?
There should be water in here, there.
Hmm?
Yeah, that was water in.
Yeah, water in and water out, yes?
Yeah.
Water in and here water out, in it. Yeah. Because if not, this will be a lot of water in it. Yeah. So water in, water out. Because the water will be here, that will cool the temperature in it. That's what you call this. That's why you call this
The cooling.
the condenser in it. Yeah, it's called the condenser. Okay. Now, explain how aspirin is separated from the impurity when distillation apparatus is set up correctly. Include the function of B in your answer. Okay. Basically, what happened is when you heat this solution, first of all, aspirin is 140 degrees. Yes. When it reaches that boiling point, what will happen?
It will turn into gas.
Exactly. Yes. Yes. It will go up. When you go up, it falls through there. Okay.
Gases rise.
The gases rise. After that temperature, you can take this one and put another one. You see? At 187 degrees centigrade, the impurity will also rise up in it. Okay. Or the impurity might be left better, or the water will rise. You can take out water from here.
It will still, because the water.
If the flask was placed in a boiling water bath and directly heated, the aspirin would not distill. Explain why.
Wait, what's the question?
If you place, instead of heating directly, you put something like a water bath, okay? You put water, hot water, boiling water, you put okay, hot water basin, and instead of heating the flask directly, you are heating the water in it. Yes, heat. So what will that affect this experiment?
It will make it slower.
Make it slower, yes? Make it slower. And what else? The consequence may not be identifiably separated, okay? Okay? They may be distinctively, because by the time even you get 180 degrees, it took a long time, innit? Yeah. So this is 6 marks. This is 6 marks for a GCSE question. So I just brought this in so that you can see what we are doing, how it relates to actual GCSE exam. We did the apparatus, we tell you, I taught you about distillation and what it does, but how to apply it in an exam is very important. That's why after we finish a chapter, we'll be going on each chapter and then look at questions in that chapter. Okay? It's very important you familiarize yourself with how to sort out questions in GCSE questions. And before the exams, you practice on the exam conditions. That's how good students do. Okay. Our topic is periodic table. We have done periodic table before, but we're now looking at it closely. Okay? Now we said periodic table is just an arrangement of elements in determined order. Okay? The recent periodic table, or the modern one,